GPT 5.5 just scored 82.7% on Terminal Bench. That's a 10-point jump over GPT 5.4 in the benchmark that actually tests whether a model can finish a multi-step coding job without you holding its hand. So what is this thing? GPT 5.5 is OpenAI's new flagship model. It replaces GPT 5.4 across the board. It's available right now in ChatGPT Plus Pro and Codex. The API is coming very soon. No confirmed date yet. When it lands, pricing is listed at $5 per million input tokens and $30 per million output. That's roughly half what other frontier coding models charge, which we'll get to. Here's why this matters if you're building a game with AI. The jump from 75% task completion to 82 doesn't sound dramatic on paper. In practice, it's the difference between a model that gets halfway through your inventory system and then falls apart, and one that finishes the job without you. That gap is your time. It's the hour you spend debugging what the model broke instead of working on gameplay, art direction, or the feel of your game. When a model handles an entire multi-file task end-to-end without you stepping in, you stop being a debugger and start being a director. For indie devs already wearing every hat, that shift isn't incremental. It's the difference between shipping this quarter and shipping next quarter. Let me break down what actually changed, because the numbers tell a clear story. Terminal Bench 2.0 is the benchmark that matters most for agentic coding. It doesn't test whether a model can write a single function in isolation. It hands the model a real multi-step task, gives it terminal access, and says go. The model has to plan the work, execute across files, debug its own mistakes, and verify the result. GPT 5.5 scored 82.7%. GPT 5.4 was at 75.1%. Claude Opus 4.7 came in at 69.4. That's a 10-point jump over the previous model and 13 points over Claude. These are OpenAI's self-reported numbers. Treat them with appropriate skepticism. But even a generous interpretation of that gap still represents a real capability leap. Expert-SWE is the other benchmark worth your attention. It measures performance on tasks that take senior engineers about 20 hours to complete. GPT 5.5 hit 73.1%, up from 68.5%, a model completing work in minutes that would cost you most of a work week. And it's not just completing more tasks, it's completing more of them in a single pass, without needing you to correct its output halfway through. Now, the honest caveat on SWE-Bench Pro, which is the other major coding benchmark, Claude Opus 4.7 still beats GPT 5.5. Claude scored 64.3%, GPT 5.5 scored 58.6%. OpenAI's own blog acknowledges evidence of memorization on this eval, which complicates every model's score across the board. The takeaway, this is not a clean sweep. If you've been using Claude Code and it's working for you, there are still areas where Claude has the edge. We'll come back to that. What might matter most for indie devs watching their budgets is cost. GPT 5.5 does more with every token it spends. According to Artificial Analysis Coding Index, it's roughly half the cost of other frontier coding models. Half the cost while completing more tasks end to end. If you're burning through tokens every day in Cursor or Codex, that's the kind of efficiency that lets you use AI aggressively without watching your bill double. At $5 input and $30 output per million tokens, it's priced to pull developers away from more expensive options. Latency hasn't changed, same speed as GPT 5.4 despite the capability jump. The model runs on NVIDIA's GB200 and GB300 NVL72 systems, and the throughput holds up under real workloads. One more detail that game devs should care about. GPT 5.5 in Codex gets a 1 million token context window. If you're working on a project with interconnected systems, combat logic, inventory, saves, UI, quest tracking, loading more of your codebase into a single session means fewer mistakes from missing context. You don't have to cherry pick which files the model sees. It sees more of your project and it makes fewer wrong assumptions because of it. Now let's talk about what this looks like in the real world, not benchmarks. An engineer at NVIDIA said losing access to GPT 5.5 felt like having a limb amputated. That's not marketing. Pietro Chirano at Magic Path had GPT 5.5 merge a branch with hundreds of front-end changes into a main branch that had been substantially modified. The model resolved every conflict in one shot, 20 minutes. Anyone who's done a messy merge knows that's not normal turnaround. Dan Schipper at Every had it reproduced the same architectural rewrite that his best engineer completed after days of debugging. The model matched the output in a fraction of the time. These aren't cherry-picked demos. This is the tedious, error-prone work that eats your day. Branch mergers, architectural refactors, large-scale integrations, the stuff that isn't fun but has to get done before you can ship. So what does this mean for your workflow? Here's the scenario that matters. Say you're building a roguelike project. You need a dialogue system, not a simple text box. You need branching paths so conversations can go different directions. You need persistence so the game remembers what a player said 3 hours ago. And you need a UI layer that renders it all cleanly. Three systems that touch each other, and if one breaks, the others feel it. With GPT 5.4, you'd break this into pieces. Implement the dialogue tree first, test it, wire up persistence, test that, build the UI. Each step risks breaking the one before it. You're managing three handoffs, each one a potential failure point. With GPT 5.5, you describe the whole thing in one prompt. The model plans the architecture across all three systems up front. It generates the code across multiple files simultaneously. It handles the data structures for persistence, the branching logic for the dialogue tree, and the UI hooks all in one pass. Then it runs its own tests to verify nothing's broken before handing the result back. Does it work perfectly every time? No. You still review and adjust, but instead of babysitting three separate tasks and debugging three separate failure points, you're reviewing one cohesive implementation. That's the difference between a tool you manage and a collaborator you delegate to. The edge cases are where it still needs you. If your dialogue system has to tie into a faction system that isn't documented clearly in your codebase, the model will make assumptions. Some of them will be wrong. The 1 million token context window helps. It sees more of your project, but it can't read your mind. You still need to be specific about constraints and integration points. Think of it like onboarding a new developer. The clearer your instructions, the better the output. The cost savings compound here too. When a model finishes a task in one pass instead of three, you're not just saving time, you're saving tokens. And at half the cost per token, you can iterate more freely. Run the task, review the output, refine your prompt, run it again. That iteration loop gets cheaper, which means you can be more aggressive with how you use AI without second guessing every request. The practical takeaway: GPT 5.5 doesn't eliminate the need to understand your own code. What it does is handle the heavy lifting, multi-file generation, integration work, the tedious plumbing so you can focus on what actually requires your judgment. Game design decisions, feel, balance. The stuff that makes your game yours. The model handles the scaffolding, you direct the building. Now the honest counterweight, because there's always one: Claude Opus 4.7 still beats GPT 5.5 on SWE-Bench Pro. And Claude Code is so popular that Anthropic literally tested removing it from their $20 Pro plan because demand was crushing their compute budget. Think about that: a coding tool so popular that the company building it can't afford to keep offering it at that price. The demand signal is enormous, and DeepSeek V4 dropped the same week, 1.6 trillion parameters, open weight at a fraction of the cost. It trails frontier models by 3 to 6 months on knowledge tasks. It's text only, which is a limitation for some workflows. But for budget-conscious devs who don't need the bleeding edge, it's a serious option. The AI coding wars are heating up fast, and the winner isn't a company, it's whoever pays attention and picks the right tool for the right task. Where does this land for actually shipping a game with AI? GPT 5.5 in Cursor or Codex isn't just a chatbot anymore. It's a junior developer that doesn't sleep. It handles multi-file tasks, it's cheap per token, and it finishes what it starts more often than anything before it. But here's the thing: the model you use today doesn't have to be the model you use next month. This space moves fast. Claude might close the gap, DeepSeek might surprise everyone, someone new might enter the ring. What matters isn't betting on one model. What matters is having a workflow that can swap models in and out as the landscape shifts. The developers who win aren't the ones who pick the best model once. They're the ones who test new models the day they drop, compare them on real tasks, and switch when the numbers justify it. If you want to see what GPT 5.5 actually does on a real game project, not benchmarks, not marketing, come check out AI Craft. We're testing it against Claude Opus 4.7 and DeepSeek V4 on actual game dev tasks right now. Real code, real workflows, real results. Links in the description.